Good day, everyone. You are welcome to Shining Video Tutorial, where we always give you the best. So in this class, we'll actually be looking at business mathematics. So we'll start with the first aspect of business mathematics. So we'll actually take a brief summary on business mathematics. So that means we'll actually be treating business maths. So one major area in which we need to understand or cover in business maths is basically our functions and equations. For instance, as far as business maths is concerned, we need to know more about what defines functions. And normally, we do say function is a relation that actually defines relations or defines rules, that relation that actually exists between two or more variables. Again, functions specify rules, is that okay, of relationships between two or more variables. Tell us what kind of relationship exists between two or more variables. That is what I actually explain the overall idea of functions. So, though we have different, for instance, if I say that I have y equals f of x. So what I'm trying to explain here is that y is a function of x. That means y depends on what? On x for its value. So it means if we are to define value for y, it depends on some determine or define value for x. So that is what I explained the overall idea of function. So in business mathematics, we need to actually know how to deal with function, how to solve some amount of function. So in start, you can actually know how to, for instance, we have some function called linear function. For a linear function, we have our y to depend on x in this way, a plus bx. So for a linear function, because it's a linear function, for a linear function, its graph is usually a straight line. The graph of a linear function is a straight line. So this is just a very good example of a linear function. So we also have a function called quadratic function. So in a quadratic function, our y depends on x in this manner. We can say ax squared. That means non-linear. Quadratic is a form of non-linear function. So we have ax squared plus bx plus c. This is a very good example of a quadratic function. This is a quadratic function here. So we have a quadratic function here. So this is a quadratic function. We shall actually explain because I'm not getting the right thing. So that's actually what we find quadratic function. The whole should be written. We find a way of writing that. So this is a quadratic function. So we also have some function here called exponential. For an exponential function, we are going to have it in this way. An exponential function will be e raised to power f of e raised to power f of x. This is a very good example of an exponential function. So that means y depends on an exponent. So this is a very good example of an exponential function. And we have more and more like that as far as functions are concerned. So whenever we have functions, say it helps us to specify relations between two or more variables. For a quadratic function now, a quadratic function, when we graph that, it's going to be in form of a curve. While for a linear function, it is a straight line. For an exponential, actually, it's going to be a curve, but it can be a discontinuous curve. It will break in some arena. So that is what actually explains these different categories of functions. So, for instance, the way we need to know function is that functions in one way or the other can easily be translated into an equation in one way or the other. So that is just how we actually explain this function. So another function can actually translate us to some aspect of equations. Because yes, in mathematics, you need to know how to deal with this some kind of maths. Is that okay? Yes, because or equation. Because when you have a business problem, when such problems are translated, they are translated in a way that it requires equation to actually what provide solution to those problems. So this problem, when translated to mathematical form, it requires our knowledge to know how to solve equations. So we need to have a good light or a good knowledge about equations. So how can we solve? How can we in one way or the other take the equation, solve the equation, and one way or the other be able to provide a neatly solution to the problem. So that will actually explain the overall point of business math and the general idea of an equation. So let's talk about let's just actually define functions, and we don't really have much. We have polynomial. So quadratic is a very good example of polynomial functions, and we have many types. It can be even, it can be odd, and so on and so forth. So we don't really need to waste much of our time on functions. So that really translates to the overall idea of, since we have a good understanding of function or an idea of function, let's talk about equation. So we have different system of equation actually. We have different system of equation. For instance, equations just explain inequality. Then in every equation, it means we have two sides, and we are saying those two sides are actually balanced. So for instance, we are saying whatever is in the left-hand side of the equation is the same thing as what is on the right-hand side of the equation. That is what actually explains the overall point of the equation. So for instance, if you tell me you actually have an equation, I'm telling you that, okay, what I have on the left-hand side is the same thing as what I have on the right-hand side. The equation comes in various forms. For instance, we can have linear equation. So, for instance, we are saying in a linear equation, we have just one unknown value. In algebraic, we have just one unknown value. And based on that unknown value, which we actually have, is that okay, we have just a single unknown value. Based on that unknown value, the power of that unknown value is of 1. That unknown value can be in x, it can be in y, it can be in z. Just think any algebraic letter to represent that unknown value. And that particular unknown value, its exponent is 1. Yes, that is what actually explains the linear. So we have also the simultaneous equation. So here we are dealing with looking for more than one unknown value. So here in the simultaneous linear equation, it means we are looking for two unknown values, and those two unknown values, maybe it's linear, those two unknown values, their highest power is what? Is 1. Yes, is 1. We don't have any of the unknowns to be in quadratic. So you can have some quadratic equation whereby some of the unknowns, either of the unknown or both of the unknown, can be in what? Non-linear form. So, but in the simultaneous linear equation, we believe all of the equations there are actually what? Of linear. And what happens? We have two unknowns to deal with them. So we also have quadratic equation. Yes. We have quadratic equation. So in a quadratic equation, what happens? The equation is generally of this form. It's of the form ax squared minus bx plus c equals to 0. This is a very good example of quadratic equation. And here, our major aim is to solve for the unknown value x. But what happens is not in a linear form. So I think we have to plus here. It's not in a linear form. That's just the issue there. Yeah, it's not in a linear form. So I should not define b to be 1 to be negative that way. So plus bx plus c. So it's the overall point is that it's there in a linear form, and the major aim is to actually get the value of the unknown x, and that value is usually 2. We call that value root. Is that okay? So every quadratic equation will usually have two roots. Is that okay? We have 2 roots. So we have ways or methods to solve quadratic equation. The most common method is the factorization method, whereby you factorize and you'll be able to get the unknown value x, that is the root of the equation. We also have that's factorization. We have the completing the square method. The use of completing the square will use us quadratic formula. So you complete the square, and once you complete the square, then you make one of the expression a perfect square. Once you complete the square, what happens? You will be able to obtain the value of the unknown. Also, in use of the completing the square, if we solve this equation with use of completing the square, we will have the formula method, which is actually minus b plus or minus becoming. So the formula is minus b plus or minus square root of b squared minus 4ac all divided by 2a. This is the formula here to actually get the value of what? Of x. So to get the known value x, we use this formula here. So I hope you have a better understanding on what actually defines the equation. So when we meet all of this in problem, I think we are going to actually enjoy ourselves and we'll see how easy all of this problem is. Now, one thing is that we also have the point of what we call the inequalities. Inequality are one of the two exact equations and functions. We use inequality a lot. Is that okay? Inequality is very helpful and is very needed. Is that okay? Whenever we have some problem to mount, yeah, we need to understand what defines inequality. What actually defines equality is just a lack of equality. That means both sides are not equal. And the basic inequality sign is the point of we saying we have a less than, and this is less than value. This is the what? Greater than sign. We have the greater than sign. So we also have the less than and equals to sign. We have the greater than and equals to what? Equals to sign. So these are the common signs in what? In inequality. Inequalities have rules. Whenever we have problem with inequalities, there are rules in which we have to comply with. We have to follow. Is that okay? For instance, when you add a value, the inequality we have two sides like equality, we have two sides, but you see that the sides are not balanced. Is that okay? They are not balanced. So when we say the left hand side is less than the right hand side, we use this. If the left hand side is greater than the right hand side, we use this. And if after it's possible that it is less than it is less than it, but it can also be equal to it, we use this. If after it's greater than 8, but it can also be equal to it, we use this. So that's what I really explain the about point of inequalities. So one thing is that common rule is that in addition, when you add is that okay, or subtract. So because inverse of addition is subtraction. So when you add or you subtract a given value from both sides of an inequality, the inequality sign will still remain the same. For instance, everybody knows that 2 is less than 3. So if I add 10 to both sides, that is 2 plus 2 plus 10. Everybody knows that it should still be less than 3 plus 10. That is the rule. I added 10 to both sides of the inequality, it still remains the same. Everybody knows that also that 2 is less than 3. If I subtract 8 from both sides, 2 minus 8, what will happen? The inequality will actually remain the same. So 2 minus 8, and that will still be less than 3 minus 8. So it's still going to be less than. So that is what actually explains the overall idea of inequality. We know that minus 6 is less than minus 5. So that is what actually explains the overall point of inequality. Also, if I multiply, is that okay? If I multiply any or divide any of the inequality sign, right? Both sides of the inequality by a positive value. Is that okay? If I multiply or divide any side of the inequality by a positive value, the inequality sign will not change. Yes, that is another rule. Now the last rule is that if I now divide, is that okay? Or multiply the inequality sign by a negative value, the inequality sign will change. For instance, everybody knows that 2 is less than 5. If I multiply both sides by minus 2, that is 2 times minus 2, what will happen? 5 times minus 2. Everybody knows that. Becoming so if I have everybody has 2 is less than 5. So if I, in one way or the other, say 2 times minus 2, is that okay? And we have 5 times minus 2. What will happen? Minus 4 is not less than minus 10, but rather it will be greater than. So the sign will change. And I hope we are going to get that. So that's why I tell you the basic rules of inequalities. All of these are what we need at the end after we use business mathematics. So now we need to move to the application now of those things in use of business and other things like that. For instance, we one way or the other in use of business mathematics, we need to have a good knowledge, is that okay, of what actually defines, is that okay? No, we need to have a sounding knowledge of business. Everybody knows that in business, we are dealing with profit, we are dealing with loss. We have to worry getting profit or loss. We need to talk about cost, is that okay? We need to talk about revenue. So all of those things are very, very important. If someone does not have a good knowledge of those things, there is no way one will be able to strive. Is that okay? One will not be able to strive in the world of business. So you need to have a very good knowledge of what defines profit, is that okay? What defines loss, but how can we actually arrive at profit, how can we arrive at loss, and all of those things. Those knowledge are very, very important, and one must have a very resounding knowledge. If you just have a resounding knowledge of those applications, it is very, very easy for an individual to actually try. So a resounding knowledge and resounding ability is needed in all of those aspects. Is that okay? Yes. That is why I always advise it. So in business, we talk about our cost function. So cost mostly depends on fixed cost and variable cost. Is that okay? Based on nature in one way or the other. So we can say, okay, cost function can be in this place. A, which is the fixed cost, plus B, F. Whereby we are saying A is the fixed cost, and our B, the B is the variable cost per unit. Yes. While our X is equal to the units or activity levels. Because of the units. So this is our cost structure there. Although some cost structure can go in terms of non-linear, we are assuming the cost structure here is linear. So also revenue. Revenue is now equal to price, which let's say the price is P, times quantity of units. Is that okay? In the period. So therefore profit is now what? Profit is now equal to revenue minus cost. That is what we find profit at any arena. So it's what the bit of profit. And also, whenever our revenue is equal to cost, what will happen? At that point, at that level, what will happen? Our profit is equal to 0. And whenever we have these two, this scenario here, what happens? We call it break even. We call these two scenarios break what? Even. When the profit is 0 and our revenue is equal to cost. Also, if the revenue is less than what? If the revenue is less than cost, we have a loss. It's not going to be profit. That's a negative profit. A negative profit means loss. So all of these knowledge are very, very important in the world of business. And their economy knowledge, their business knowledge is okay in one way or the other. There are things that we really need to know. So if we have a better knowledge and understanding of those things, I don't think we are going to have any problem. So those things actually require the knowledge. They require the resounding knowledge and abilities. So if they have a good knowledge about them, there's no way we are going to expect to have any problem. So the next thing that we need to talk about here, we can really run through some economics applications. Yes. But those things here are, we talk about the profit maximizing level. Profit maximizing level for the firm. At the profit maximizing level is okay. Our marginal revenue, additional revenue in the period must be equal to the additional cost, which is the marginal cost. Everybody knows that marginal revenue is always the additions, is okay. Additions, now revenue that a firm receive as a result of selling an extra unit or additional unit. So, in our knowledge of differentiation, we say it is the change in our revenue to change in the units, which is our X. Yes. Also, our marginal cost is the additional cost as a result of an extra unit. So it's always, what defines that is change in our cost to the change in the, to the units as a result of selling an extra unit. So all of this are straightforward knowledge. So they are straightforward knowledge that we should try to have. So if you have them, I don't think we are going to have any problem. So this is the profit maximizing level. I really want you to forget. Although when we treat differentiation as well as a topic, I'm very confident that we are going to understand and our confidence will be improved upon. But these are just the basic knowledge that if we can have it, it will be very easier for us to actually pick and have a resounding knowledge and understanding about what actually define all of this concept. Thank you.